Hello, welcome to session 3 in Arduino Programming Fundamentals. In this session we are going to be working with motors. So, motors can be fun. You can see on this little picture of a very unfinished R2D2, I've got a little Arduino powered by 4AA batteries that are feeding into a little motor driver that's turning the little motor that makes the dome rotate. And from the Arduino we can control the speeds, the direction, whether it goes slow. We could use other sensors to make it look in a specific direction, in the same way that Alexa knows which way a voice is coming from. Okay, so this is what we're looking at today. We're going to recap our use of iteration, as in loops, and we're also going to relook at our selection, as in if statements. These are the sort of end products that I tend to make, these little robot cars, and you can see I'm just using a little bit of breadboard with an Arduino Nano, an extra little chip just here. I've since modified to use a proper PCB, makes it more robust but less versatile, much harder to add extra parts to. So again, breadboard's great for getting ideas working. Okay, so this is what we're basically looking at. We've got the Arduino Nano, and again an Arduino Uno will do just the same job, but as you saw on the previous slide, I liked it because it just connects together on a breadboard nice and neatly. So this is a little chip called an L293. These are really good for driving those little yellow robot motors you see quite a lot on eBay and Amazon. The L293, as it says there, it just acts as a buffer. We cannot just hook up these pins directly to a motor on and off. We will destroy the Arduino. I know, I've done it. I destroyed a lot of little PIC chips, for those who know what they are, by trying to drive motors directly before I learned about these little things. They cost about 50p each. You can buy them in bulk and get them a lot cheaper. I mean, as you can see from this little chip, we've got the ground, so we can connect the grounds together. Output 1 and 2 are the bits that we connect to the motor, so the motor connects to both sides. Input 1 is where we just hook that directly to one of our output pins of the Arduino. Output 2, again, another pin. The enable 1 and 2 is just us saying we can activate this chip. Now I cheat a little bit at this point and I just hook up 5 volts to all the corner pins. But the VSS is where the main electricity should come from that powers your motors. In the real world we cannot just use the 5 volt feed to actually power the motors. On this little one I've got a 4AA battery pack that goes directly to the motors and goes to the Arduino, so I'm feeding both. And I'm a little bit naughty, I don't use a voltage regulator. Okay, so this is what it might look like in Tinkercad, where I've got all these wires, but obviously I'm going to show you how we can make that. So if I just jump back into Tinkercad, I'm going to create a new circuit. Again, I'm going to make sure I choose an Arduino. Now there's no Arduino Nano in this, so I will be sticking with the Uno, but again makes no difference whatsoever. I'm going to look for an L293. L293, there we go. I forgot to add a breadboard, so I'll just put that there for the moment. I'm now going to get a breadboard. Okay, so there's a breadboard. Now again, these pins are connected, but this allows us to have like a bridge in the connections. So if I just drag that straight over, I've got my L293. Now if we look back at the slide, they are pretty much symmetrical. So it doesn't really matter which way around it goes at this point. If you're using more complicated, it might be important. And just like before, I'm going to connect the ground. Put that out of my way a little bit. Now I said the middle pins are ground, so I'm just going to connect that to there. I believe these are all soldered together on the inside, so it doesn't require anything else. Sometimes I do connect them all up, other times leave them blank. It'll do for now. I'm going to connect pin 2 to our enable. Sorry, not to our enable, to our input. That says there, that's input 4. I'm going to connect pin 3 to our input, which I believe is input 3. Again, it doesn't matter which way around they go, because in the code we can so easily change it. For the sake of neatness, I'm going to use the analog pins, which I'm just going to try pin 5. We can use analog pins as digital pins, so I can still say on and off. That's where it gets a little bit messy. And same again. And again, this is where colour coding kind of comes in because it starts getting really ugly at this point. So I'm not going to get any points for that. And now voltage. So if I drag voltage to there, I can't believe how ugly I'm making this. I'm just going to make that a different colour so I can see what's going on. I should make this a whole lot neater. And now I can just connect the 5 volts straight to there. Again, 5 volts straight to there. And again, I'm going to make these red so they do stand out a little bit. If you've got your own colour scheme, then obviously please do go for it. I'm going to connect that one to there. Again, red. I'm going to connect that one. And again, red, so I can just see where it's going. So we've now got obviously the power coming in, and it's all grounded, and we've got the control pins all connected up. Yes, it looks ugly. That's why PCBs become so nice. So now I just need to add a motor. So again, I'm going to come over here. Just type in motor. These are the ones that I tend to use in my little robots, but for the sake of this demonstration, I'm going to use DC motor because I can see the actual cogs, the gears whirring around, so I know if it's working or not. And I'm just going to connect that straight to that point, that straight to that point. And again, I'll just change these colours so it's a bit easier to see what's going on. I'm just choosing kind of colours at random at this point. I'm going to drag another motor. I'm going to rotate this round just so it looks again kind of symmetrical. Drag another wire. Okay, and another wire. Okay, what do I go with? So that'll be yellow. It can take a bit of trial and error to make sure you know which pins are driving which ones, but again, not a big deal really. Okay, so we've now got our circuit, as long as I've not made any silly mistakes. But like I said before, you would not do this for real. You would not drive the motor voltage from this 5 volt input. You'd use an external battery pack that would feed into this chip and into the Arduino. Okay, so on to code. I'm going to make a couple of little changes now, or should I say enforce a couple of things that I mentioned earlier. Obviously I don't want the LED flashing anymore, so I'm just going to delete that bit of code. Because you might make a mistake, you might cross these wires over when you're making a real thing, I'm going to go straight in with labelling our pins. So int motor 1 forwards equals pin 2. Int motor 1 reverse equals pin 3. So if you make a mistake on the wire in itself, you just change these numbers around so you've got them doing it the right direction. Int motor 2 forward equals, so I said it was A5, so if I just put in A5, that should work. And then int motor 2 reverse equals A4. So again, trial and error might be needed. And just like before, I want to go pin mode M1F output. It is case sensitive to make sure you do it correctly. Motor 2 reverse, I'm just setting them all to outputs. So motor 2 forward, and then finally motor 2 reverse. So they're now all set to outputs, obviously. So inside our loop, what I'm going to do is I'm just going to make one motor turn round, stop, turn round, stop, and so on, as though it was driving forwards indecisively. So if I now say digital right, open bracket, M1F high, I then want to let it drive forwards for 1 second. I'm then going to copy and paste again, as I said before, a bit lazy. Digital right, low, so I'm turning the motor back off. Okay, so now we should see this turning, then stopping, provided I've done nothing wrong. Oh, I've broken my chip. That's a first. Okay, the reason's really obvious, and again it's because I'm talking while I'm trying to do some wiring. I've connected the 5 volts straight to this side of the chip. What I've not done is connected 5 volts to this side. I've connected this rail, but there's nothing actually connected to it. So if I just drag that pin to that pin, I've now got electricity all the way around these little red strips. Again, simple schoolboy error. So if I now try it again, press start simulation, we should see, there we go, the motor's now turning, stops, turns, starts, and so on. If I want to make it go reverse, again I can just copy and paste this bit of code, but this time I can change it, rather than motor 1 forward, I can take it motor reverse. Okay, so it should now go forwards for a second, stop, go reverse for a second, and stop. So if I now run that program, forwards, backwards, or clockwise, anti-clockwise, and there's our little robot control. We'd now do the same thing for the other motor. So again, if I was to come just here now, let's say we're trying to make it drive forwards, but like a tank would, if I just come straight in at this point and say motor 2 forwards, and then making sure I turn it off as well. Okay, so motor 2 forwards, and make that low. So if I was to run this program now, we should see them both turning at the same time. Then they stop, then only that one moves, because I've not told that to reverse. So this would make our little car kind of start doing some odd rotation and driving forwards a little bit, look like it's kind of limping. Okay, so that's really it for this tutorial. It just gets the motors kind of turning for the moment. And we've got the whole thing in a loop, so it'll just keep on going. I'll just show you some slightly neater code. Again, it's pretty much the same thing, but I've written some comments in. Obviously, if you're doing this for real, do make sure you've connected to the correct pins, the pins that are correct for you. Also, do not set all pins to high at the same time, because you'll be trying to make it go forwards and backwards simultaneously. It'll just generate lots of heat and it will break something. But notice what I've done with this bit of code is I've modified it so not just the loop function, I've written a function called drive forwards, so that inside my loop I just use the phrase drive forwards, and it calls this little function down here that makes it run. And then I've got a function called stop all. It just sets all pins to low. It just makes your code look a little bit neater. I may talk about this in a later point. Your goal now would be, can you make it move forwards for a set amount of time, then make it spin? Could you make it go forwards for a set amount of time, then reverse, then spin? Could you make it do something random, so it moves for a random amount of time before changing direction? It's great for doing sort of children's toys. You could aim for doing some little kind of patterns, so it does stuff like this. The other way, if you want to control the speed, we've just turned the pins on and we've held them on for 100% of the time. If we want to change the speed, we basically turn it on and off really quick. It's what's referred to as pulse width modulation. It's how a lot of radio control cars have been working for years. To give you a quick look at how that would work, if I come back here, let's say I say we go high, but I only let it go high for maybe 50 milliseconds, and I say then turn it off for just 50 milliseconds, that's kind of really fast, but it's going to go on, off, on, off, on, off. I could then put that in a little for loop just like we did earlier, for int I equals 0, because I'm just going to start at nothing, I equals 0, I less than, let's see if we do it 50, so 20 times, which means it's going to drive for 1 second at half speed, I plus, oops, I forgot to put my brace around it, so put a brace just there, come down just here. This will now drive forwards for 1 second at half speed, and again you can experiment with these numbers a little bit. So if I just play that, it looks a bit glitchy, but if it was in the real world it would work just fine. Okay, I'm going to leave that with you for the moment. In our next lesson we will be looking at ultrasonics, how we could make these reverse if an ultrasonic sensor is triggered. Okay, so check it back next time.